Okay, so let's start our conversation about problem number 7. So question 7 says, I have NH3, which is a weak base. What, or would you expect it to be a good acid? What is the value of Kb, Ka, NH3, NH4 plus, H plus, and OH minus? So I know it's a weak base. If I know that it's a weak base, I can look at the exam handouts. And actually, let me open. Should have opened that first. I apologize. Okay. So I can find my exam handouts. Yay, exam handouts. And I can scroll down to my weak bases, which are like all the way at the end. So let's see, acid ionizations, acid base properties of salts, diprotic acids, standard enthalpy, standard hydrogen, entropy, reduction potentials, enthalpy. Those are KSP values. Oh, that's right. Okay, bear with me. Sorry, this is an older version. I apologize. I forgot that I fixed this for you guys and didn't have a copy of it here. So let me. And yes, I am going to do this. Be this stubborn. Yeah, I know how. Okay. Ah, yes. My weak bases. My last page that I didn't have on the other thing. So I apologize for that. Anyway, looking at ammonia, that's right here, NH3, that's that. And I see that the Ka or Kb that's listed Kb that's listed here is 1.8 times 10 to the minus fifth. I also see that the conjugate acid, NH4 plus, has a Ka listed of 5.6 times 10 to the minus 10. So that's a couple of the questions that they asked me. They asked me about what's the value of Kb and Ka. I have both of those. So I can put those down on my sheet, and actually you can see from the exam handouts I have Kb equals 1.8 times 10 to the minus fifth. Ka for NH4 plus is 5.6 times 10 to the minus 10th. Now if you didn't have both of those values, if you only had Kb or if you only had Ka, you could find the other one. Divide that value into Kw. So Kw divided by Kb is Ka. So we could have taken the 1 times 10 to the minus 14th, divided it by 1.8 times 10 to the minus 5th, and that would give me 5.6 times 10 to the minus 10th. That is not a good acid, because I asked you if it would be a good acid. It is not a good acid. So let's continue on. It is not a good acid. I have found Kb and Ka. Now, if I want to find my NH3 concentration, then I need to look at what exactly I have for my Kb. So my Kb equals NH4 plus times OH minus over NH3. I know that if I want to find the concentration of OH minus, right, that's going to be equal to the square root of Kb times NH3. Okay, so that's that. I also know that if I wanted to solve for NH3, typically I wouldn't be able to do that. I would have to know that. But that is something that I can do. So I don't necessarily know what NH3 actually is. If they give me a value, I can do something with it, but I won't know its native value. Okay. I know that OH minus is equal to NH4 plus. Both of those are equal to each other, and that's this expression right here. If I'm looking for H plus, also 1 times 10 to the minus 14th over OH minus, or 1 times 10 to the minus 14th over Kb times CH3 will give me that expression. Okay, so that takes me through all of the things that they've asked me. Questions, comments, problems on any of that? Hope not. If we do, then you know how to reach me. I will talk to you soon.